Hello. So my colleague Joan and me would like to present you Orion project. Uh, we actually presented it a couple times yet, but seems this is not quite enough to get the code very stable. So we have broke our presentation into two parts. First one will be about details I'm working on, and another one will be done by Joan on quota in Orion. So originally Orion started as an effort to run Lustre on ZFS, and we actually tried a number of approaches, like we tried to run Lustre service in user space on top of a regular POSIX file system and so on, but finally we end up with the most obvious approach where all Lustre services still run in kernel, and we introduce single storage abstraction, which is literally OSD API. It was introduced in 2.0, and it was used at that point, and now in current release branch it's used only for metadata operations on MDS, and we left number of redundant APIs to still run OSS, MDS, object operations, LLog, MGS, and so on. So as part of our current Orion project, we made a number of changes to OSD API itself. So now we reach enough to implement all the remaining services like OSS, like all the features and components of MDS and MGS. So they all now in our Orion branch use OSD API. And old APIs soon will be removed or cleaned. Like, for example, LVFS has been already removed from our branch, and we plan to remove many OBD methods as well. So another thing is that as part of this work, we got better defined MDS stack, where we replaced a number of old modules like LOV, LOC with new modules which work only with OSD API. And for example, module OSP, which replaces OSC on MDS, isolates everything related to network from MDD and so on. And we also think that all these changes simplify the code a lot, which is known to be the source of many bugs. So some benefits we get with OSD API. So the most obvious one is that now it's much easier, or probably better to say it's now possible to use different backend file system with Lustre, because Lustre core is now separated from specific storage details with OSD, using OSD API. So right now, as a primary goal of our project is to run it on ZFS, and well, there will be a report from Brian Bellendorf about how it actually behaves like right now. So we looked closely on Btrfs, but at the moment we think that it's not quite solid for our purpose. Probably at some time in future we will look again and try it. Another interesting thing is that with OSD API it's now become possible to use non-file system backends like database system, for example, to store metadata. But at the moment this is just a theoretical speculation. So as I said before, the code in general on MDS becomes much easier because a lot of functionality separated into different modules, and interaction between modules is much easier and very well defined. And API itself is, I believe, it's now very clear semantically, and modules solve their only problems internally and try to avoid involving different models where possible. And all this, I believe, should result in much less efforts to become Lustre developer, and we would like to see more development from the community. So, just very short overview of what specifically we have changed in OSD API. First of all, we got two-stage transactions. It's mostly inspired by ZFS because this is how transactions in ZFS are organized. And you have basically in every transaction you have two stages. First one where you declare all the changes to be made, possible changes, and then you execute your changes. It's also important that with two-stage transaction we cleaned up LDiscFS related code a lot, and we got rid totally of magical credit numbers from the code except OSD related to LDiscFS. And transactions, also important that transactions now are stackable. So when you plan on some transaction, you don't need to think how it will be implemented and what kind of changes it will be done down to a stack. So on every layer you only care about things you do. We also got a few methods to manipulate data, like zero copy IO methods, truncate. This all is needed to implement OBD filter, which is now called OFD device in Orion. And as part of this, we also put all the caching on all of functionality related to caching under specific OSD, because the implementation can be very different. Like with LDiscFS uses page cache, for example, ZFS uses own caching mechanism called ARC, and so on. Plus, we got pair transaction commit callbacks, which we used to have in 1.8, but then we lost it with master branch. And this one should simplify implementation of features like HSM. Another pretty big change in Orion is that how OST objects are destroyed. Historically, in 1.8 and 2.0, destroy RPCs are sent by the clients to OST, and due to this design, there were a lot of complexity in current MDS code to exchange cookies and so on, just to implement this trivial distributed transaction. Plus, another side effect is that in some cases, like double failure, when MDS fail and client fails as well, you can get files with no objects, which is not fatal, but I guess can be annoying in some cases for some customers. So in Orion, we changed this model to different one, where corresponding unlink is first committed on MDS, and only after that MDS send or destroy RPC to OST. So unlink now becomes really atomic, and to save traffic between MDS and OST, we use batching. Another, so it's slightly unrelated to this slide, but I just put it here. Another interesting thing about using OSD API and is that actually this is the very first small step towards distributed operations, really distributed operation in Lustre. Because if you think about file removal in Lustre, you need to remove object on MDS and set of objects on OST. So this is distributed operation, and it's interesting that with OSD API, it's actually semantically very clear that you just like MDD start transaction, and then in the stack down you destroy local object, and then you destroy remote objects, and then you stop transaction. So there will be a talk by 1D about how this trivial example actually can be used, and it's already used to implement DNE phase 1, where you may have several metadata servers. So you can see this is as how stack looked or look on 2.0, 2.1, and how we changed it in Orion. First of all, we have it's a bit easier to understand, and the more important is that the number of different sort of APIs have reduced, and you can see that below MDD, it's OSD API, the same OSD API is used between modules, and the only exception is that to store log records, OSP itself internally uses a log API. So this is that simplification I mentioned before. Also, this is kind of model or how functionality is broken between modules in the new stack. So on MDT layer, we basically implement Lustre protocol, which is you can imagine think of that as a way to actually save RPC. So instead of sending, when you open or create file with Lustre, you actually do number of POSIX operations, like you open, like you create it, open the file, get regular attributes, get some extended attributes like striping information, and then put this all into a single RPC and send back to the client. So Lustre protocol combine number of POSIX file operations into one RPC. Then MDD actually implements these POSIX operations from primitives, which we call updates. Say regular file creation usually contains object creation plus a new entry in a directory. Below, we start to use OSD API. So all those primitives actually represented by specific methods in OSD API. And LOD, which stands for Logical Object Device, it actually hides everything about striping on MDS. So MDD, basically, and MDT, and none of modules except LOD actually know anything about striping, which is good from layering point of view, from maintenance point of view. And below LOD, we have two sort of devices. One primary one is OSD, which is actually a representation of local file system on the server, and we have number of OSP devices which represent remote Lustre servers in this stack, and they actually again they export all the functionality like object creation, like object removal, whatever, behind OSD API. So it simplifies code a lot. Well, basically that's it. So now Johan will be talking about how Quota is implemented in our project. Thanks.
So I'm first going to present the global quota architecture, and then I will focus on the changes we have made in Orion. So what's the goal of quota? The purpose of quota is to prevent a single entity from consuming all the resources of a file system. So an entity can be a user, a group of users, or it can even be a directory, for instance, if you want to have a per directory quota. Then we have to identify the resources which are involved. We obviously have two different pools, an OST pool and a metadata pool. And then we are going to account for a unit for each entity. So on the MDT pool, we decided to account for inode. So we track the number of inode used by each user and each entity in general. And we do the same on the OST pool, where we account for blocks. So we have this global quota limit, which is set by the administrator. And then we have to distribute this space across several servers, because Lustre is a distributed file system. In order to achieve this, we use a master and slave scheme. So we have the quota master, which is in charge of the global quota limit. It is the only one who has the global view of how much space is consumed by a given entity, given user or group. And then it distributes the space to the slaves, who are in charge of making sure that a given user cannot overrun its local quota limit on a local target. So all slaves are typically composed of OSTs and MDT, and the quota master, as of today, runs on MDT 0. So let's have a look at the request processing when quota is enabled. So a client sent a write request to an OST. In this case, the OST is the slave, or create a file on the MDT. In this case, the slave is the MDT. So the slave received this request. It was initially granted some amount of quota space. So it estimates the space required in order to handle the operation. It checks how much space is free locally. If it fits, then it's fine. It just processes the request and return success to the client. If, like in this slide, the slave is out of space, it then has to acquire more space from the quota master. So it sends a quota acquire RPC to the master. Then the master checks how much space was already granted to all the slaves against the global hard limit, which was set by the administrator. And if it can satisfy the request and grant more space to the slave, it will return success, so space granted to the slave. Then the slave now has enough quota space in order to process the request. So the slave just processes the request and returns success to the client. Now, if the master is out of space, it has already granted all the quota space to the slaves. It cannot satisfy the acquire request sent by the slave, and the master just returns ED quote, which means quota exceeded, to the slave, which then forward this error to the client. So this is the global quota architecture. Now in Orion, so as Alex explained, the main goal of Orion is to be able to run with different backend file systems, to run Lustre independently on top of LDiskFS or ZFS. So as far as quota is concerned, this means that we have to sit on top of the OSD API and not to make any assumption on the backend file system. So this is the main change that we are doing in the Orion branch on quota. And then the new quota architecture comes with a new reintegration procedure, which allows a disconnected OST, so an OST which slaves in general, which was not connected to the master, to fetch all the new quota settings at time when it reconnects to the master. So this reintegration procedure allows us to have efficient handling of OST addition. So in 1.6, we added the feature to allow, thanks to the MGS, the ability to add an OST online, but unfortunately, it does not work well with quota today. So with this new reintegration procedure, then we can handle online OST addition and populate the quota settings on the new target, which just joined the file system. And now we can also run a quota command while some slaves are missing. So when you run the command, you will just reach the master, which will record the new settings, and then it will be in charge of pushing all the new quota settings to the slaves. So in the current architecture, in 2.2, you cannot run any quota command, LFS quota command, if one slave is missing. With this new architecture, you will be able to run command, and then if OST are there, then fine, they will get the new settings. But if they are not connected at this time and join, connect to the master lately, they will fetch the new settings. The other change we made is that on the MGS we have per file system tunable, and unfortunately quota was still enabled on a per target basis. So this means that if you want to turn on quota, you have to run a lctl conf param command for every single target, which is part of the file system. And now with the new architecture, we have a global per file system parameter in order to turn on and off quota. The new architecture also supports DNE, so multiple MDT, which will be presented just after this talk. So it just means that inode quota is now managed in the same way as block quota, so it is distributed, unlike the architecture we have today when it is centralized on MDT0. The new architecture allows to support per pool quota in the future. So for now we only have 2 pools, the MDT pool and the OST pools, but in the future we might want to have the SSD pool, the OSD SSD pool, the MDT SSD pool, and so on, and to have different quota set on a per pool basis. The new architecture also allow us to have per directory quota in the future. So the main change is that the ID used to identify the entity, so it has been extended. By default, in Linux, a UID or GID is a 32-bit field. With ZFS, it becomes a 64-bit field. And if you want to have per directory quota, you need to use an ID which uniquely identifies a directory. And in this case, this is the file ID used in Lustre, which is a 128-bit field. So we have extended the quota ID field to be 128. And if it is a user ID, it's smaller. But if it is a feed, a directory feed, then it can be used for this purpose. In Lustre 2.2 and in previous version, we had no slave to master connection. Actually, this was the MDT which connects to the OST. And then on the OST side, we had to track the reverse import in order to send RPC from the slaves to the master. This is quite painful because this means that each time the MDS reconnect through a failover server, for instance, this import is changed, and we have to raise an event across the stack in order to track all changes done on this import, so that quota has always a valid reference. So this code was not very great, and we decided that we need a slave to master connection, which is needed anyway for feed on OSTs, which is a requirement for DNE. So quota is now going to use this slave to master connection, and now that we have a real connection, we can afford to enqueue DLM locks, which was not possible on the reverse import. So now with the DLM locks, we can afford to grant quota space to a slave and to grant a lock at the same time in order to protect this quota space. And more importantly, it allows the master to revoke space granted to a master to the slave, through standard LDLM mechanism like DLM callbacks, which are already proven to be scalable because it is what is used between the client and the server in Lustre. Another major changes in the architecture is that now the quota master tracks the space distribution. How the space is distributed across slaves. Currently in 2.2, the master just stores the sum of the space which was granted to all the slaves. It has no idea of how the space is distributed. It just knows that it granted this amount of blocks and this amount of inode, but it does not know how much is consumed, for instance, by OST0 or OST1 and so on. So now we have a per slave index which tracks the space allocated to slaves. And this allows us to have a better recovery resiliency. Now we can handle recovery just between the master and the slaves. It does not involve consulting all the slaves in order to handle recovery properly. And it also allows us to implement dead OST decommissioning. So if an OST is dead, you can just run a command on the master, which will just go through the slave index of this OST and release the space which was consumed by this OST, which was not possible, which is not possible currently in Lustre 2.2. As I said earlier, we also introduced a new per file system parameter, which is managed on the MGS. So you now enable and disable quota on the MGS through a lctl conf param command, which is what we use already for OST pool configuration. So a few words about space accounting. So traditionally in Linux, quota on and quota off not only disable quota enforcement, but it also disable and enable space accounting. And so this means that if you turn off quota, create some file or delete some file, and then turn on quota, you have to scan the file system again in order to fix space accounting. This is what we call quota check. And we exported this ability at the Lustre level with LFS quota check. ZFS took a different approach. They decided to always track per user and per group space consumption, and then quota on and off just act on enforcement, and accounting is always enabled. And coincidentally, Google has posted some patches to adopt the same behavior on top of LDiskFS, on top of ext4. So we decided for Orion to use this feature, and so that we have the same behavior with on top of ZFS and on top of LDiskFS. So this means that there is no more LFS quota check. Accounting is always enabled by default. The way it works is that when you run at MKFS time, we create empty quota files, which are always up to date because LDiskFS will maintain this accounting on disk. And then when you run LFS quota on or off, you just disable enforcement. So if you run LFS quota off, you won't get ED quote anymore, but accounting will still be enabled on the backend. And no more quota check. And the good news is that now E2FSCK can fix the quota file. So for instance, if you have some major corruption with LDiskFS and a file is removed, currently the quota accounting is not fixed. It's not updated. E2FSCK has decided to kill some blocks, but the quota file are not fixed. And now with this new approach, E2FSCK will fix the quota accounting in the quota file. So I mentioned earlier that we have a new slave reintegration procedure. So it replaces the existing quota recovery. And so how it works that it allows slaves which were not connected to the master to fetch the latest quota settings when they reconnect to the master. And this is actually a 3 steps procedure. The first step is that the slaves reconnect to the master and re-enqueue a lock, a generic quota lock. And in the reply of this DLM enqueue, the slave gets the version of the quota object. Then the slave can check the current version of those objects against the version of the object it has on disk. If there is a version mismatch, it fetches the latest quota settings through a LDMA from the quota master, and then it parses the new information and acquire or release the quota space and re-enqueue per ID quota lock. If the version matches, then nothing is needed. So finally, a comparison with today's quota. So the current quota architecture was first introduced in Lustre 1.4, and we have been porting this architecture from 1.4 to 1.6 to 1.8 and to 2.x without any major changes to the architecture. And sadly, some new features have been added to Lustre, and those features don't get along with quota at all. So for instance, the MGS was introduced in Lustre 1.6, and quota was still using a per target parameter, while the MGS allows you to define per file system parameter. Also, the MGS allowed us to handle online OST addition, but unfortunately, as of today, it's still not possible to push the new quota settings, the quota settings to a newly added OST. You can run quota check. It will create the quota file on the new OST with what just been added, but unfortunately, all the quota setting, all the history of all the settings you set, all the limits you set for a given ID won't be pushed to the new OST. And thanks to the new reintegration procedure, then we will be able to deal with that. So we now have a more friendly interface, a global parameter, as I said, a more robust quota implementation, which thanks to the reintegration procedure and the fact that the master now tracks the usage of how much was granted to each slave in a dedicated index. With Orion, we are now backend agnostic, so we sit on top of the OSD API and can run independently on top of LDiskFS or ZFS. And we have a better integration with other Lustre components because we leverages the DLM and we also use feed in order to identify quota objects. That's it.
Okay, we're slipping on time, so unless there's a crazy burning question,
Yep.
well, there's a crazy burning question.
Did you address performance hits at all in this? I know that enabling quotas slowed things down before, since it's now always on.
So you mean on the accounting or on the cost of accounting, of enabling accounting permanently, or just the cost of the new architecture?
The cost of the accounting.
The cost of the accounting, yes, we measured it, and it was totally neglectable. For accounting, the fact that we maintain the quota file. No, accounting is always enabled too, so you can have a cost even if you don't enable enforcement. Okay. Yeah. Ah.
Question.
Sure.
Is you plan to count blocks, data blocks used on MDT?
No, we don't plan to account for this.
So, United the service alone if someone create a large directory.
Yes. So if you create hard links, for instance, yes, you will be able to consume blocks. But the thing is that you set a different limit, and usually the limit you set on the OST pool is usually way bigger than the MDT size. So even if we acquire blocks from the OST pool, it does not help you, because usually the quota you set is way higher than the MDT size.
I say about different thing.
Okay.
If someone set global file system limit for this user,
Yes.
so it will become block sizes on MDT or not.
No, it will be an inode, number of inode. That's the same interface as today.
So if a user will be create a very large directory on MDT, may consume all MDT space and provide the out of service for MDT.
Well, if you create a very large directory, you will create a lot of inode, right?
Not all.
What do you call a large directory then?
You make use something like nodes or other where.
Yeah, so it will create an inode, and you will be limited by the inode limit, right?
Only,
The only problem is with hard link, I think.
So it should be accounted as a nodes and not directly on data blocks. That
Yes, so as I said, we account for inode on the MDT. So if you get a huge number of file, you will allocate a huge number of inode, and you will be limited by the inode limit. The only corner cases is with if you create a hard link. With a hard link, you don't create a new inode, right? So in this case, yeah, you will be able to fill the MDT, but this is the case already today, since even if you acquire space from the OST pool, it does not help you, because usually the limit is way bigger.
I don't about OST pool.
Okay,
No, I mean,
you guys need to take
Okay.
this offline, because we're way over time. Thanks so much, thanks so much. Let's give him a hand.